Good morning. Welcome all to our today's presentation that is on penetrant testing. So penetrant testing is a surface oriented inspection to determine the defects into the ferrous and non-ferrous material which are laying into the surface of your inspection part. That means any defect which are associated into the open conditions of your inspection part, either it is ferrous or non-ferrous, that can be identified with a high level of sensitivity into the liquid penetrant testing. In simple way, liquid penetrant testing we can say it's a advanced version of visual inspection. That means penetrant testing increases the seeability of the small discontinuities that the human eye might not be able to detect. So in this training session, we will be discuss regarding the general introduction, basic penetrant material, step of the penetrant inspection, common equipment, advantages and limitation of liquid penetrant test, and overall whatever we have been learned that we will be summarized. In liquid penetrant testing we know that we are clean our inspection surface by the applications of some solvent or cleaner, and then we are applied the penetrant. After certain time period the penetrant will be removed. The penetrant will be entrapped into the cavities by the process of capillary action, and when the entrapment is completed, depending upon the opening of the defect, size of the defect, surface wettability condition and temperature of the job part and type of defect also, after that, which is known as penetration dwell time, excess penetrant is removed from the surface, and then we will apply the developer solution. Developer will mix the blotting from the entrapped penetrant, and after drying the developer will produce a white contrast layer, and in the white layer you can identify the bleed outs of penetrant which are in a specific color of dye. Now the question is how the penetrant test is working. That means the basic principles of the penetrant testing is capillary action. That means each and every liquid has a tendency to entrap into the cavities due to the capillary action. Simply the example of capillary action is like that transportations of water into the plant from the soil or from the whatever the plant is exist, and the transportations of blood in our human bodies from the life sustaining blood into the capillaries path, that means the veins or something. So these all are the examples of the capillary action. So in general, liquid penetrant testing has a 6 step. In step 1 we are clean and dry the component, then we are applying the penetrant. After certain penetration dwell time we are remove the excess penetrant. Finally we are dried the component if we are applying the water for removing the excess penetrant from the surface. After the drying we will apply the developer, wait for the development time, and after the development time we will visualize the bleed out of the penetrant into the surface of developer. Visual inspection is carried out within a certain time period, and after the interpretation during the visual inspection, entire inspection part need to be post cleaned. Now the question is what type of material we can carry out the penetrant testing. Almost any material that are relatively smooth, non-porous, and where the discontinuities are open to the surface, this type of inspection part can be inspected by the liquid penetrant testing. That means the basic condition is the inspection surface shall be non-porous in nature. Any material which are porous in structure like pure nickel or iron carbide, that cannot be inspected by liquid penetrant test. Show the component with the rough surface such as sand castings that trap and hold the penetrant. We cannot carry out the inspection in such material. Porous ceramics, wood and other fibrous material, certain kind of plastics which can take part into the chemical reactions with the penetrant cleaner or developer, that means the chemicals whatever we are using in penetrant testing, if that is make reactions with that particular type of plastic component, it can able to peel it, and this kind of material cannot be inspected by penetrant test. And the component with coatings that prevent with the penetrant to entering into the cavity. So any kind of painted part, material which has carried out the painting, wrapping or coating, this kind of material cannot be inspected by penetrant test. In different industry, in the different form of product, we can identify the defect by the application of penetrant test. In rolled product like cracks, seams and lamination in case of casting, defect like cold shut, hot tear, porosity, blowhole and shrinkage in case of forging lap and forging burst, and in case of weld inspection, cracks, porosity, undercut, overlap, lack of fusion and lack of penetration during the root inspection particularly, we can able to inspect it. If we are talking about the types of material using into the liquid penetrant test, so there are two type of penetrant using into the industry. One is type 1, that is known as a fluorescent, and type 2, that is the visible. That means the fluorescent penetrant is containing a certain type of dye which can respond in the presence of ultraviolet light, and when the ultraviolet light will be impinged on the fluorescent dye, it will absorb it and give you the visible spectrum in a certain color range. In generally green to yellow color we are observing during the presence of ultraviolet light if we are using the fluorescent dye, and in generally the fluorescent dye that give you the color of green to yellow into the UVB light. Visible dye is basically red in color, and the visible dye means we can visualize as dye into the white light, and depending upon the nature of how you will remove the penetrant from the surface, depending on that there are 4 type of penetrant using into the industry. Method A, that is known as water washable. Method B, that is post emulsifiable lipophilic. Method C, that is a solvent removable penetrant, and method D, that is the post emulsification fiable hydrophilic. In the same way, whatever the developer we are using into the industrial practice, there are 4 type of developer we are using: dry powder, water soluble, water suspendable, and non-aqueous solvent suspendable. The name of the testing implies that it is known as a liquid penetrant test. So here the two terms is there, one is liquid and another is penetrant. So all the liquid we cannot say it's a penetrant. Penetrant means it has some penetration ability, and the penetration ability developed in such kind of liquids which bear some specific characters. What are the characters? The first character is the liquid shall have a tendency to spread easily over the inspection surface, and it is only possible if its surface tension is less. And second thing, when we are applying this liquid into our inspection part, it will be cleaned with your inspection surface with a definite angle which is known as contact angle, and this contact angle shall be less than 90 degree, which will produce a liquid column which is concave in nature. And if the contact angle is less than 90 degree, it will raise the capillary pressure of the liquid during the entrapment, such that if the contact angle is less than 90 degree and the surface tension is less, then the liquid has a maximum tendency to create out the maximum capillary pressure, and the liquid can be entrapped into their cavities in a most sensitive way. It shall have a nature that it will be drawn into the surface breaking defect by the capillary actions or other mechanism. It will be remain liquid form during the penetration dwell time. It has the ability to dissolve the dye such that we can able to produce the specific color of the dye, like that a visible dye, red in color, and fluorescent dye which is green to yellow in color. Definitely the liquid that will be using as a penetrant, it shall be chemically inert. That means any kind of toxicity, flammabilities, that will be under control, such that when we will using that liquid penetrant during my inspection, it will be not harmful to the inspector. If we are talking about the level of sensitivity into the liquid penetrant testing, sensitivity of liquid penetrant test are divided into the 4 level 1, 2, 3 and 4. Level 1 is considered as a low sensitivity level, level 2 is the medium sensitivity, level 3 is the high sensitivity, and level 4 is the ultra high sensitivity. So these levels of sensitivity is only applicable to the fluorescent type of penetrant only. When we are using the visible and fluorescent penetrant parallelly into the two different parts during the inspection, from the quality and sensitivity point of view, fluorescent penetrant will give you the maximum level of quality compared to the visible dye, because visible penetrant is performed under the white light while the fluorescent penetrant is performed under the ultraviolet light. Why the fluorescent penetrant is much more sensitive compared to the visible dye? Because visible penetrant is usually red, and red standouts and provide a high level of contrast against the light background. And in case of fluorescent penetrant, green to yellow color is in generally using during the absorption of the ultraviolet lights, and the green or yellow color, the eye is much more sensitive in this color region due into the green, and due to that the number of arrangements of the cones or the color receptor present in our eye, that will make you the maximum sensitivity when we are using the fluorescent dye. Depending upon the removal process of the penetrant, there are four type of penetrant is there using in industry: solvent removable, water washable, and post emulsifiable. What type of penetrant we are using, that depends upon in which industry we are going to use it, and what is the severity of the defects which we need to be identified. In the same way, 4 type of developer we are using, that is dry powder, water soluble, water suspendable, and non-aqueous solvent suspendable. Whatever the penetrant we will be used, according to that composition, we are selecting the developer solution. That is selection of penetrant and developer depending upon one to another. So in gist, we can say in the penetrant test there are 6 steps: pre-clean, applications of penetrant, excess penetrant remover, developer application, inspection, and then post-clean. Pre-cleaning is the most fundamental and most important step of the liquid penetrant testing. During the pre-cleaning, what we are doing, we are applying the solvent or cleaner directly into the job in your inspection part. And pre-cleaning is most important in the sense that during the surface finish, whatever the mechanical activities we are doing, like that grinding, buffing, or some kind of blasting, in that scenario we are producing some smeared metal into our inspection surface, and those smeared metal can close the opening of the defect. So the removal of smeared metal is most mandatory, such that the penetrant can entrap into the cavities. And the second thing is, when we are applied the cleaner or penetrant and remove any kind of contaminants from your inspection surface, like oxides, scale, peat, or any kind of oil or grease type of material, and your surface, if it will be smooth in nature, definitely the surface energy of your inspection part will be increases, and if the surface energy is increases, it will increases the wettability of the applied penetrant. So before the applications of penetrant, we need to be done the pre-cleaning in a so serious way, such that the surface energy need to be increases. So this is the examples that a inspection part before the pre-cleaning and after the pre-cleaning. If the smeared metal is removed from that, there will be a lot of microstructural changes occurred into your inspection part. After the pre-cleaning process has been completed, we are applying the penetrant. There are different type of technique is there for the applications of penetrant, like brushing, spraying, dipping, immersion, flow-ons, or others. But be remember, the application process of penetrant is an essential variable for liquid penetrant tests. So the application process need to be mentioned into your procedure, and whatever the procedure, whatever the technique that has been written down into the procedure, that need to be followed. After the applications of penetrant dwell time, penetrant into your inspection part, we need to be removed for some times, that is known as penetration dwell time. The penetration dwell time in generally, we are follow the ASME section 5 requirement of penetrant test in article 6. But the thing is, depending upon the type of defects, and the second thing is, whatever the opening of the defect is there, we are normally calculated the type the penetration dwell time. But in generally, for the determinations of the welding, casting, and forging in generalized defect, the penetration dwell time will be 5 minutes if the temperature of the job part are laying within the temperature range of 10 to 52 degrees centigrade. But in generally, penetrant test can be carried out into the temperature range of 5 degrees centigrade to 52 degrees centigrade, as per the ASME section 5 article 6 requirement. So if the job part is in the range of 10 to 52 degrees centigrade, it will be 5 minutes. But if the temperature is more than 5 degree but less than 10 degree, the penetration dwell time will be double, that will be 10 minutes. After the application of penetrant and the dwell time has elapsed, the excess penetrant that will remain into the surface, that need to be removed. Depending upon the removal process, there are 4 type of penetrant is there. One is known as solvent removable, second water washable, lipophilic, water washable, third one post emulsification, payable, lipophilic, and hydrophilic. Whatever the maximum use is there into the industry is concerned, we are using the solvent removable penetrant. In the solvent removable penetrant, we need a lint free cotton cloth, and we will dampen the lint free cotton cloth by the cleaner or remover, and in a single direction, either into the clock or anti-clockwise direction. In a single direction, we will be move the lint free cotton cloth such that the cleanup is done. But vigorous applications of the lint free cotton cloth, a moistened cloth, need to be avoided. we cannot apply the solvent or cleaner directly into the inspection surfaces, because if we are applying the cleaner directly into the inspection surfaces, then the evaporation of the liquid that will be laying into the surface, if it's happen in the similar way, if the penetrant entrapped into the cavities, that will be also evaporated, and the penetrant entrapped into the cavities, that will be removed, and we will be not able to identify the defect, and no bleed outs will be there. Water wasable penetrant, that is known as a self emulsifiable penetrant. Emulsification process is nothing, it is a special kind of chemical which will react with the penetrant, which is in generally oil base, and when will be chemically react with the penetrant, it will dissolve the oil to the water soluble product, and if we are applying the water spray into your inspection part, excess penetrant will be removed. So in case of water wasable penetrant, we are using the coarse water spray in use to remove the excess penetrant, and the procedure used as a guideline for the inspection will specify the water temperature in the range of 50 to 100 degree Fahrenheit, and the pressure of the water, spray water or rinse water, that will be maximum 40 psi. In case of solvent removable penetrant, we are maintaining the timing such that the excessive flooding or excessive cleaning has been not done. In case of post emulsifiable penetrant, there are two type of penetrant is there. One is known as lipophilic and another is hydrophilic. The working principle of both the emulsifier or penetrant is different. Lipophilic emulsifier working in the process of diffusion, and the hydrophilic emulsification process is working principle is the detergent action. In case of post emulsifiable process, there is a concern about the removing much of the penetrant from the defect. A post emulsifiable penetrant is in generally used. It's the most sensitive process. This involves an additional step in which an emulsifier is applied to the surface of the part of the penetration dwell time. Emulsifier is given just enough time to react with the penetrant on the surface to render it the water washable, but not enough time to diffuse into the penetrant trapped into the defect. So after the application of penetrant and penetration dwell time, we will apply the emulsifier. Emulsifier will be react with your excess penetrant into the surface, but another time is not given, and then we spray the water into your inspection surface such that the excess penetrant will be removed from it. After the removal of excess penetrant, whatever we are using the water for the removing purposes, we need to be dried the entire inspection part, and after the dry we will apply the developer. Developer is in generally the pyrolytic silica powder, and this powder we can use in the form of dry powders. Otherwise we can use into the wet solution, and the carrier of the wet solution, it may be the water or it may be some liquid hydrocarbon, that is known as non-aqueous wet. And in both the cases, in case of water we can use it into the in general soluble condition, or otherwise into the oversaturated condition, that is known as suspendable. In case of non-aqueous hydrocarbon based developer, we are using a liquid hydrocarbon, and in that developer powder are mixed up with a high level of concentration, that is into the oversaturated, such that when we are using the non-aqueous developer and we are not using for the prolongated time, all the developer particle will be settled down. So before the applications of developer, we need to be shake it 4 to 5 minutes before the application to make it a homogeneous mixture. So whatever the developer we are recommended to use, if we are using the solvent removable penetrant, according to that non-aqueous solvent suspendable developer in generally we are using, which will give you the maximum level of sensitivity. After the applications of developer, we will be wait up to 10 minutes, that is known as development time. But in case of non-aqueous solvent suspendable developer, after it dry completely, you can start your inspection, and during the inspection you will see you, if it is the visible dye, then in a white background there will be red bleed outs, and in case of fluorescent dye we need to make the necessary arrangement such that your inspection surface will be semi-darkened into the condition. A ultraviolet light is required with a minimum level of intensity of 365 nanometer. Inspector need to be taken some specific kind of eye protection. That means some kind of goggles need to be used, because ultraviolet light is harmful to our human eye. And into the semi-darkened conditions, if the ultraviolet light will be impinged into the fluorescent dye, it will absorb it and give you the visible spectrum color range into the 525 to 565 nanometer, which is in the range of green to yellow. So green to yellow bleed outs will be there in fluorescent dye, and red indications will be there. During the inspection or interpretation, the inspector need to have the ability to identify whether the defect is a true in nature or false in nature. Any kind of geometrical indication, that will be considered as a false indication. Rest of all, that will be considered as a true indication. If it is the true indication, then inspector need to be identified whether it is a relevant or non-relevant. If the dimension of the indication is more than 1.5 mm, it will be known as a relevant indication. It is less than 1.5 mm, it will be known as a non-relevant indication. All the non-relevant indication will be considered as acceptable. If it is a relevant type of indication, that indication need to be recorded, whether it is a linear type or rounded type. And after the identifications, the nature of the bleed outs, either it's a linear or rounded, it will be marked into your inspection part, and the post cleaning will be done such that all the chemical residue will be removed from your inspection surfaces. There are two type of penetrant system is there. One is the portable penetrant system, and second is the stationary penetrant system. In generally, in case of construction where the portability is much more required, we are often using the portable penetrant type. In penetrant system, we are using a cracked control panel, particularly nickel chrome test panel, to identify the performance of the chemicals or the liquid penetrant bath during the course of inspection. So cracked control panel we are using to identify the system performance of the liquid penetrant test. Liquid penetrant testing has a lot of advantages because it is relatively easy to use. Initial equipment investment, costing, training and interpretation skill is to develop that interpretation skill, and it is not very difficult in process. We are using the portable equipment, so in areas where the accessibility is a very concern, we can easily able to carry out the small portable tanks, and we can carry it out, and on the spot information it can be able to collect. The limitations of the liquid penetrant testing is only the material which are non-porous in nature and the defect which are open to the surface that can be identified. If the geometrical abnormalities is there, a critical job geometry, there is a possibility of excessive background, and in that scenario it is difficult to inspect the in a correct way. In case of liquid penetrant testing, during the inspection, if the inspector has been identified whether the nature of the defects is linear or rounded, according to that the inspector need to be taken the decision whether it is acceptable or not. In generally, every specification has a definite standard to accept the liquid penetrant test, but most suitable and most what we can say most stringent code of inspection for the liquid penetrant test we are considering as a mandatory appendix 8 of ASME section 8 division 1 for the acceptance of the liquid penetrant test. So ASME section 8 division 1 appendix 8, that is the acceptance standard of liquid penetrant test. If the specifications or client requirement or engineering designs specify the other code, that is a different thing, but in the most stringent way we are considering ASME section 8 pressure vessel code with the division 1 appendix 8. According to that, any kind of linear indication which is relevant in nature, that is not acceptable, and if rounded indication is there, any indication which is rounded in nature, that is acceptable, is up to the 5 mm, it is random in nature, and 4 or more rounded indication is acceptable in a line separated by 1.5 mm edge to edge distance. So this is the acceptance criteria, according to the liquid penetrant test. So during the inspection, the type of defect need to be identified in the nature of linear or rounded, and the length will be measured, dimension will be measured with a industrial scale. And if it is linear in nature, regardless of dimension, it is not acceptable, and if it is rounded, then you can accept it up to the 5 minutes, but the inspection need to be carried out within the 60 minutes. So that's all about the liquid penetrant testing. I hope the entire thing that has been covered in this training session. For the further clarifications or any kind of inquiry is there, you can contact me in my mail ID given here, guptasisdas@gmail.com, or the contact number given into the screen. For further clarifications or any kind of doubts is there, you can WhatsApp me in the same number that is given into the screen. Thank you everyone for listening. Hope parallelly the next video will be there into the another topic of NDT. Thank you.